All right, let's find the derivative. Clearly, we want to use implicit differentiation. Here we go. 2x plus 8y times dy dx using the chain rule. All right, derivative with respect to x of 6x, and for minus 8y, it's minus 8, but then times dy dx. And the derivative of 9 is 0. Okay, next we're going to isolate our terms that have dy dx in it. Let's subtract 2x and subtract 6. We subtracted them from the left, and they're gone. We subtracted them from the right, and there they are. Now we'll factor out this common factor of dy dx. Divide both sides by 8y minus 8. Simplify this expression. Factor out the negative 2 in the top. Factor out a negative 2 in the bottom. And the first derivative is x plus 3 over negative 4y plus 4. All right, let's go on to the next part of this problem. Where are the vertical tangent lines and where are the horizontal tangent lines? Well, consider this pink graph, a graph that has vertical and horizontal tangent lines. What can you say about the slope of this horizontal tangent line? Because dy dx represents slope. Slope is 0. So we can find wherever there's a horizontal tangent line. And I'm not saying this pink circle is the graph of this. It's not at all. I was just pointing out that a horizontal tangent line has a slope of 0. So whatever this looks like, we know that the horizontal tangent lines will occur when the slope, is 0. And what can you say about the slope at any graph's vertical tangent line, assuming that one exists? Well, the slope of a vertical line is undefined. How is a rational expression undefined? When we have the divide by 0 error. Therefore, for the next two parts of this problem, we'll find the horizontal tangent when the slope is 0 and the vertical tangent when the slope is undefined. Well, when is this expression 0? When just the numerator is 0. And when is that slope expression undefined? When the denominator is 0. So the horizontal tangent line exists when x is negative 3, and a vertical tangent line exists when y is equal to 1. But this problem asks where are the points that the graph has a horizontal tangent line and a vertical tangent line. So we just have to go one step further in both cases and find the respective missing coordinates. We have the x-coordinate, what's the y-coordinate of the point where there's a horizontal tangent? And we have the y-coordinate, what's the x-coordinate of the point where there's a vertical tangent? So we'll come up to the original function here and substitute negative 3 in for x and solve for y, and substitute 1 in for y and solve for x. There's our substitution in for x, and here's our equation when we substitute 1 in for y. Solving each of these, we get, on this side, y is 0 or 2 when you follow the algebra, so our points are negative 3, 0, and negative 3, 2. And then for where our vertical tangent lines are, we just need to solve this for x. Combining like terms, factoring, using the zero product property. One of those factors has to be 0. So x is 1 or 5. So when x is 1 or 5 and y is 1, these are where our vertical tangent lines are.